Hello. Today we are going to start our lecture on formula nodes. How formula nodes work in LabVIEW. So let us create a new VI. Okay. Okay. Select formula node. We are going to have some input and then output. We are going to create a program, simple program. See, I said in earlier lectures that programming is used in LabVIEW, but for a very short, for very short parts. Control. We have input variable. Let's create y as an output, as we are all familiar with it. Okay, get an indicator here. Okay, so y is equal to x square plus x plus 4. Don't forget the semicolon. Okay, let us see. After this, we are going to do some experiment with voltage and current values and find active and reactive power. Okay, let's see how that goes. 0 at 0 it is 4, obviously. At 1 it should be 6. Okay, and at 2 it should be 10. 2 square 4 plus 2 plus 4. Okay, so it is 10. Brilliant. Now let us do something a bit advanced, just a bit advanced, not that much. Okay, we have voltage values. Okay, so voltage. Okay, then we have current, control, okay, then we have value of theta, which is angle between voltage and current waveforms, which is theta, of course. But in LabVIEW, when you give angle to trigonometric values, it considers in radians. We have to change it. The value we are going to type will be in degrees. Okay, we'll have to change those in radians, assuming we are taking a control here. Okay, have to just cut it here, delete. Okay, this cross sign, how would you diminish it? Just control B it. Just control B it. Okay, it's done. Okay, now we'll select a divider. Right. Divided by 180. We'll multiply by pi, which is 3.14. Multiplied by pi. Okay. Okay. 3.14. Okay. You can also select pi as a constant number. Okay, there are a few constants. Yep, mathematical constant here. You could select pi as a constant as well. So we'll just push it here. Okay. So let us give it theta, or angle would be much better. Okay. So this let us create P as active power, because using voltage, current and angle between them, we can get the output of active power and reactive power. It will be active power. And you can have another output, that is reactive power. Okay. Okay. Have to select P is equal to V into I to cos of theta. And we can select Q which is equal to V into I into sine of theta. Okay, okay, this is it. So through this we can select here. Okay, so we'll have voltage, active power, reactive power. These are inputs. Angle, have current. Okay, make it a bit here. Okay, it is more visible. Okay, assuming we have 220 volts with 1 ampere current, and the angle between it is 35 degree. Okay, now with these values we can actually get the values of active and reactive power. 180 watts is reactive power, and 126 VAR, volt amp reactive, is going to be our reactive power. You can prove it. V into I, so it is 222 volts. But the formula of apparent power, and if you only have voltage and active power and reactive power, you could just unroot them and add them and square them simply. You could find the apparent power. And you only have voltage and current, if only you could multiply them and find the apparent power. So if we multiply 220 with 1, it will be 220 watts or apparent power, which is VA, volt amperes. And if we underroot, and or let me just show you how it's done. So you can also add this S. You can add S is equal to V into I. Okay, add S as an output. S. Okay, indicator will be apparent power. Apparent power. We can see it will be 22. Now we have to find apparent power from active power and reactive power. So we'll further do something. So we have active and reactive power right now. We can select another such thing, another formula node. Okay, structures. The two inputs P, add input Q. So connect it here, connect it here. So we can write value. So it will be, you can write equation as, so we'll have S as an output further. Output as, have this indicator, power. Okay, right. S is equal to P, let's give brackets first, will be P square plus Q square of minus 2, which is under root 2. Okay, this should give us the value that is, okay, let us add here. Okay, right, so this is the apparent power that we should also get 222, and we didn't. Okay, okay, so no, I think I made a mistake. Okay, so here it will be 0.5. 1 by 2 is actually under root 2. Sorry, I made a mistake. It will be okay. Let me see here. Okay, now let us see. So it is 22, right? Okay. So I guess that's it. That is how we use formula node. It looks a bit confusing, but if we focus on the formulas and work it step by step, we could create so many things, so many projects through this. Okay. So bye bye.